that's the whole thing, right? I mean, I guess there's artists and there's artists. I mean, that sounds bad. But again, from a business standpoint, if your market, if your demographic, your goal is to go after the Fiverr market, then yeah, of course, you're going to get destroyed by this crap. Right? Because again, if you're going after the Fiverr market, what is the Fiverr market? The Fiverr market is one off, it's inexpensive, you do not have to be perfect, it's not going for quality, the whole nine yards. And so, yeah, so if you're a mechanical Turk of the artist world, yeah, fine, this is going to put you out of business. But again, are you an artist then? Here's the thing, though. You got to think about it as a business standpoint, right? If you are really a commercial artist, right, you're a graphic designer or whatever, you're not just selling this. That's what people miss. That's one of the big things people miss. You're not just selling this. You're not just selling an image. You're selling a brand identity, right? You're selling that the color scheme on everything matches. The color scheme from the logo matches the website, matches the clothing, matches the billboard, matches the business cards, all of that kind of stuff. The fonts just don't match across the board, but they also make sense with whatever it is that you're creating. That you're selling it's lifestyle brands. Again, one of the interesting things in 2000 came about, right? Manufacturing. We finally figured out how to manufacture crap at scale. And again, in the 2000s, if you started reading marketing books back in 2000s, right? Before times, right? There was these big questions about why Patagonia. Why buy Patagonia when you can go to Walmart and get quote unquote something that's just as good? And the reason you buy Patagonia over Walmart, one is quality, but it's quality, it's look, it's feel, it's a specific color, it's the lifestyle. I am a Patagonia person. I ain't no Walmart person. Right? Where you got Walmart people. I say, we're Walmart people. We ain't no Patagonia people. Right? It's a fucking coat, dude. Keeps you warm or dry or whatever else, right? You're not selling the product as much as you're selling the lifestyle. And so one of the things to be thinking about, again, if you're going to be supporting businesses, if you're going to be an employee, right? You don't got money coming out your buttocks and you actually have to be an employee or a contractor. One of the things to think about when you're going to your business customers is how do you sell them that concept of lifestyle for their corporation. They're not coming to you for a picture. They're not coming to you for a fucking logo. They're coming to you for brand image. And if you can sell brand image, right, this is just going to help you do whatever it is that you're going to do. If you're selling Fiverr art, you're fucked. What do you want me to tell you? That's how it works. That's how it works in the real world. Don't tell people about the real world. They start to cry. So anyways, there we go. Got enough people in here. It is 2:08, so I guess we're going to start our DIY class today. And basically, with these DIY classes, the idea is that I'm putting projects together to try to show you folks how to solve problems. So again, one of the interesting things that I find in the technology world nowadays, again, especially for me, I started in 96, got my MCSE back in 2000, is back in the day, I got paid to fix it. I would walk into the office, I was told it wasn't working, and by God, it needed to work in about an hour or two. Right? Again, I was thrown in. When I was 24 years old, I had to support the networks, the NT, Windows NT infrastructure. I had to support the telephone system. I had to do build outs. I had to frickin' do everything. And basically, whenever I called the higher ups to ask them a question, their answer was, I don't know, figure it out. So anyways, one of the interesting things that I see nowadays in the modern world, especially with a lot of young people, is, and when I say this, this is not meant to be insulting, it is actually very concerning, but we have the highest educated, least competent generation out there at this point. We have a huge number of people that are highly educated, they know a lot, they can pass a lot of tests, but can they build a damn thing? And here's the thing. We get paid to build. We get paid to solve problems. We do not get paid to pass tests. And so basically the idea here is with all these different things that we're doing, since we're using Python and Bottle and AI and all that kind of stuff, basically trying to create these projects so that you get a better idea of how to actually solve problems. Where it's not simply a REST API call, it is not simply doing a query to a database, it's understanding how all of this stuff goes together. And I will say before we get into this, trying to teach that's a hell of a lot harder than I thought it was going to be. It's a hell of a lot easier to explain REST API calls than it is to try to put these projects together. So we will see how all of this goes. Again, if you're new here, basically just so you know, Silicon Dojo is authorityless, gatekeeperless, free to end user, hands-on technology education that empowers you to do whatever the hell it is that you want to do. I will say that free to the end user is not actually free. We're trying to abstract out the financial component from the education component, but we still need a financial component. We have a DonorBox account, donorbox.org/ETCG. If you'd like to throw a couple of dollars in there, that would be ever so lovely. If you have questions at any time in Zoom, Mike has already done it. I'll get to you in a second, Mike. You can raise your hand in Zoom, and I will try to answer you when I look at the screen and I have a moment. Copyright, basically everything that we're doing. You can take it, you can use it commercially, whatever else. I am in Asheville, not Silicon Valley. I don't believe every damn thing in the world needs to have intellectual property rights. Tippy tap or die, again, everything that we're going to be doing, the idea is for you to actually build stuff. Again, if you just want to sit there, you can sit there, but you're not going to learn how to be a technology professional. Extra help, w3schools.com is fabulous. Again, for Python, CSS, HTML, SQL, absolutely great service. And ChatGPT is phenomenal. It is not AI, but it's still incredibly useful to use. We use VS Code with the default settings because that is just how we standardize everything. You can use whatever IDE you want to use. If you actually want me to help you, it's easier to know if I know what colors I'm looking at, that kind of thing. Material, just so you know, again, all of these classes now, they are getting recorded for the Eli the Computer Guy channel. So if you don't know me, I've got 1 million subs on YouTube. We've got the Eli the Computer Guy channel. All of these classes are being recorded in 4K and will get uploaded within about a day or so after I finish these classes. And on GitHub is where all of our class material is. So GitHub/Silicon Dojo/online-classes. You can come here, all the classes we do, the lab work, the books, again, the slides, the material, everything else is there. I'm also starting to do these cheat sheets. There's not much to it right now, but basically for a lot of the stuff that we use in these classes, basically put it in the cheat sheets. So when you start to do your projects, you can just, again, copy paste because that's what coders do. Let's see here. Beyond that, trolls don't care, and we'll talk about that one later. So yeah, let's get in the class, but Mike has his hand up. What's up, Mike?
Typed a question in the chat.
Oh, you typed a question. What do you build that generates revenue? Did you? What? I'm muting you, Mike. Mike! What are we doing in life? This is a class. What do you mean? What do you build that generates revenue? You build whatever you want to do build that generates revenue. Did you do your Windows 2000 accelerated module? Yeah, Mike, I'm put your hand down, Mike. I'm just going to lower your hand for you. If you have questions relevant to the class, there are no dumb questions. There are freaking relevant ones, though. Let's keep it relevant. This isn't YouTube, just so everybody understands. This will get uploaded to YouTube later. This is not YouTube, though. I'm here to teach classes. That's it. Mike. People are getting to know you, Mike. You're starting to become a meme, Mike. Just putting it out there. Just gonna put that out there. Okay, so let's run through and take a look at the projects that we're going to be doing today. Then I will try to explain the code. I'm actually probably going to be charting out the code more than hyper explaining the code, just because I do realize sitting here and trying to explain 160 lines of code. Holy shit. That is more difficult than it sounds. Well, all you have to do is sit there in front of a board and explain your code. Yeah. Yep. Yep. Not quite as easy as you think. So anyways, so what we're going to be using today, again, the technologies that we're going to be using today is Python, of course. We're going to be using the Bottle Web App Framework, and we're going to be using SQLite, and we're going to be using all of these because they are dirt simple. Before anybody asks, no, none of this crap is deployable. Well, not really deployable. Here's the thing. When people ask questions like, is this deployable? It's like, well, we need more information, bucko. We need more information. So here's the thing. If all you're going to be doing is running these apps basically on your computer, which might make a lot of sense. Again, one of the nice things about Bottle is you can simply run the script, and from running the script, you have a web application that you can use locally. So it might make a lot of sense to just build something that you're going to be using locally and nobody else is going to be messing with. So if that's what your consideration of production is, sort of, probably not the best idea in the world, but also not the worst idea. One of the things to understand, though, is whenever you're going to be actually deploying apps into the real world, is that, this is one component. Again, we talk about that tech stack, that stack, right? And so, again, whenever we're looking at Python, right, so we got our script here. So we got our nice little Bottle script here, and this is the thing that's going to be creating whatever. At the bottom of it, we're going to be using the run function. So there's a run function that you put at the bottom, and that runs the script. Well, the important thing to understand is when you trigger the run function, it is actually going to run with a web server. Right, so there's a web server. So normally, when you hear of web servers, you're probably thinking about Apache, Nginx, maybe IIS, but IIS is still around. But that's not really what we're looking for here. Basically, we're going to be triggering a Python web server. So if you've dealt with Django, if you follow my Django classes, you will have heard of something called Gunicorn. And so Gunicorn is actually a Python web server that basically tries to package all this up. And again, there's a lot of stuff in there with how communication and sessions and all that kind of stuff is done. And this tries to provide a better environment for your users. There are probably a ton of different Python web servers out there. Gunicorn, again, seems to be the popular one. And if you follow me for any length of time, that's basically how we do things in these classes. I'm not saying it's the best, but if it's popular, we're just going to go with it because people know about it. But here's the thing. Even when you got Gunicorn, that's not necessarily the end of it. Generally, it's not going to be the end of it. You want to put Nginx in front of it. So you're thinking about Nginx, it's considered a web server. So if you're going to create a website with HTML, CSS, WordPress, something like that, you would normally just dump that into an Nginx server. The interesting thing with Nginx, though, is it also works as something called a reverse proxy server. So the reverse proxy server is when users come in, it is able to actually route traffic internal to your network, but with part of that, it has caching mechanisms. Again, it also has improved ways for dealing with user communication, especially at scale. And so basically, you would put Nginx in front of your Gunicorn. That would be presenting your Bottle web app, and that is what would allow people in the real world to get access to Bottle. And that's a class. That is a class unto its own, and we're not going to be getting into it today. So basically everything that I'm going to be showing you, you should be able to run locally, again, on your local LAN as a, if you want users in your house to be able to access this kind of thing, that's probably fine. But again, if you're actually looking at putting this into a production environment, the stack for putting this into a production environment is bigger. And this is why things get complicated in the technology world. Again, I really want you to understand this with technology. Technology is dirt simple. Technology is simple. Python is simple. Bottle is simple. SQL is simple. CSS, HTML, web servers, TCP/IP, all of this horse crap is simple. I can teach you the basics of all this stuff within a couple of hours. But here's the thing, right? You have the operating system, and then you have the networking, and then you have the Python, and then you have the Bottle, and then you have the Nginx, and then you have the security things. Right? What makes our profession complicated is not the individual components. All of them are very simple. It's building all of this into your stack to actually be able to deploy solutions. So, okay, we're gonna go through. So we're just gonna keep these to 5 projects. Again, I tried to do 7 projects last time. That sucked. That was bad for everybody. So we're going to try to keep these DIY classes to 5 projects. Basically, the first project is a basic. So we're going to create a little web app so we can talk to OpenAI, see what that looks like. And then we're going to start creating injections. So we're going to give ourselves a little HTML form so we can actually inject injections. We can add rules whenever we're getting responses back from OpenAI. We're going to then give it a memory because OpenAI, the API by default, doesn't have things like memory. So we're going to give it a memory. Then we're going to have a gallery, so Dolly gallery, so we can make queries basically in order to create images, download those images, and then search, because that's one of the big things right now. Like everybody's going out there and they're searching for images, but then the images disappear after a certain amount of time if they don't download them. This script will automatically download them and add them to a database. And then we have a gallery search. Basically what the gallery search does is you put images into a folder and then processes those images through OpenAI for it to determine what's in the image. That information is saved into a database, and then you can search for specific types of images. So that's what we're going to be doing today. Okay, so we got bottle. So this is going to be, let me scoot all of this over by like foot. Okay, so our basic app, right? So again, we're going to come down here whenever we run this. So we're putting local host here. So you can have local host, you can have 1.7.0.0.1, you can have 0.0.0.0. We have local host because that's what I copied and pasted. Let's be honest. Then we do port 8080. Port 80 is the default port for HTTP. If you run this with the correct security privileges, you can run it at port 80, and you can just put in 127.0.0.1 or whatever, and that's it, and it'll just show up. We're not running it with those privileges, so we have to plug in :8080. It's a TCP port, as we've talked about before. So let me run this thing. And so this is the basic app. If it's running properly, we'll see this local host, and we can go over here and okay. So if you look up here, I don't know if you can see this, 127.0.0.1 :8080. And basically this is just really simple. So we got the OpenAI app, we have home, so we can go back, and then we have a question. This is a query. So I can say, how are you doing today? Because it's AI, so I want to be friendly with my AI. Anyways, I can hit the submit. This is actually getting processed through OpenAI's API. You will see this is pretty simple, quick here. So query, this is a query. Response, I'm just a computer program, so I don't have feelings, but I'm here and ready to help you with anything you need. How can I assist you today? Right, basically I can go back and I can click on home, and I can say, how big is a cat? I can hit submit. On average, domestic cats weigh between 8 to 10 pounds and measure blase, 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 blase. So anyways, basically what this shows you is you're able to use an HTML form to submit a query to OpenAI, and it is going to send the response back, and then you can put it up here. Again, the important thing to understand in the technology world is once you can put something into ASCII text, it is very, very, very easy to deal with. Getting a computer to understand what something is, right? Getting a computer to understand that this is a dry erase marker, that's hard. I'm not that smart. Once a computer tells me this is a dry erase or dry erase eraser, that's a lot easier to process and to deal with. And that's the important thing to understand here, is once we can get this to ASCII text, we can start doing a lot of cool stuff. Oh, let's see here. Anyway, so that's the first project for you. Then we're going to stop. Always remember, when you're running these, to do these, if you're going to do the code, always make sure to run the code so it's actually running, and then kill it so it's done before you run the next thing. Then we're going to do the injection. So this basically allows us to inject into things. So I can simply do home, because I'm using the same stuff. So you'll now notice there is home and there is rules. Ooh, cool. So we can go over here to rules. And we don't have anything here in rules. So I can say set always say dude. Always say something about pasta, answer in less than 50 words. This is a big thing to be thinking about with injections, even if you don't want to screw around with your users. Just simply injecting, limit the damn answer to something can be very useful. OpenAI can be a bit verbose. Just do remember, OpenAI gets paid based off of the tokens that are spent. The longer the response, the more money they make at the end of the day. So just telling it, hey, I'd like to keep it at 50 words, that might be a useful thing. Anyways, I can now hit submit. I go back to home and I can say, I don't know, what is a cat? Hit submit. Dude, now look at this. See, I've got injections. Dude, a cat is a small furry animal often kept as a pet. It's like the spaghetti of the animal world. Comforting and enjoyable. So it says, dude, it throws pasta in there, and it keeps it to under 50 words. And so what's really cool about this is because injections are huge, right? And again, they talk about prompt engineering, so that's the big thing, is how to do the prompts. I think one of the more interesting things, especially as sysadmins, again, actually building this stuff, is going to be how do you properly build these injections. So you want your users, to be able to ask whatever they want, but then you don't want the system to necessarily answer all of that crap, right? And so one of the curious things here is one of the reasons that this is a useful tool is it's a very easy way for you to go through. You can add rules, you can remove rules, you can see what the responses are in a relatively simple format. So basically that's the idea with that particular project. Stop, always stop, and now we're going to give it memory. Does it have memory? I don't know if it has memory. Okay, we're going to go home. Now we have a memory tab. Oh, it has memory. Let me pause this for a second. The database is memory, as I call it. Yeah, memory database. I'm going to kill the memory. I don't want this thing to have a memory. So move it to trash. There we go. Okay. So we're going to start this again. So basically now, with this particular script, we're going to start giving our AI memory. And one of the things that you can do with memory is you can start triggering based off of keywords. So basically, when you make a query, that query is going to get saved to the database along with the response from OpenAI. One of the things that we're going to do is what we did with that injection before. What we're going to do now is we're going to do a query, and we're going to look for where the user did a query. So select all, or select actually query or whatever, from the memory table where the basically query is like, I want you. Right? So I want you is going to be a trigger set of words to say that I want you to do something. Right? So I can come here and I can say, what is a cat? Submit. Right? And it tells me what a cat is, and you can see it's a lot more verbose. I can go back to home. How big is a cat? And then, again, pretty verbose. I can come here to memory, and what we're going to start seeing here is basically this is just simply pulling from the database, and we get what the query was and then what the response was. And so this is useful for a number of reasons. One of the things you need to be thinking about is for your employees. So for all of you out there who are employees right now, again, we always talk about bias. We always talk about teacher bias, anybody's bias. My bias is to get you folks to be decision makers, right? The point is to get you promoted to be the assholes. Anyways, and so one of the things you have to be thinking about is with your employees is, oh God, you can't stop your employees from being so freaking stupid, but you can try to mitigate their stupidity. Right? And so one of the things you can do is by having a system like this that creates memory, and again, especially if you can start tagging this, you can start tagging with things like IP addresses or user accounts or whatever else, is you can go through and you can simply audit, what the hell kind of questions your users are asking. Because again, what seems funny to one employee is what will make the other employee sue the ever-loving crap out of your company, right? Again, if you have somebody, you create this great little AI system and you want it to help people figure out how to do, computer code or whatever else in your particular environment, and then, you get the tech bros in there who start asking AI about Kama Sutra movements. You should probably be able to check up on that kind of thing. And that's one of the useful things by having something like memory. So anyways, one of the things I can do here is, so I can do question, basically it's query. I want you to always say dude. I'll put it between there. I don't think it'll kill it. Okay, so we do sure thing, dude. How can I help you today? I can go back to home. I say, tell me about cats. And I can do submit. Please work for me today. There we go. Sure thing, dude, right? Because we're triggering off of that memory. And so basically we're creating the injection based off of I want you to always say dude. Right? I can go here and again, very simple. I want you to always answer in less than 30 words. Hit submit. I do home. Is a cat better than a dog? Submit, dude, and now we can see that it's much shorter. So again, we're giving it that memory and we're triggering for actions basically off of words. Mike, gotta ban you from the fucking group, Mike. This isn't that place. This isn't that place. This is not YouTube. I'm smiling. Anyways, so the next thing we're going to do is a gallery. So I think this is a big thing to be thinking about now. So again, with ChatGPT, with a lot of these other LLM services or multimodal services, whatever the hell they're called now, basically you're able to create images. So that's one of the things that a lot of people are doing. One of the issues though is that if you create the image and then you do not download it or you do not save it, it basically disappears. So that's one of the big things, again, especially dealing with the OpenAI DALL-E API. Basically, it'll create the image for you, and then it will give you a URL to that image. So it actually goes up to Azure's data store, and it will stay there for approximately 1 hour. So if you put in this really great prompt, you get back an amazing image, and then you share the URL with the other decision makers in your company. They all agree that's the best image that's ever been created, and you go down to download it. If it's been 1 hour and 5 minutes, it might have gone bye-bye. Right? And so basically what this script allows you to do is it allows you to create the prompt. One of the interesting things with DALL-E nowadays is it actually creates a revised prompt. So you give it a prompt and then it does a revised prompt. So it kind of fleshes it out and then it gives you the image. And so what this will do is it'll save to the database, the prompt, the revised prompt, the image name, and it will actually download the image name or the image into a folder so that it's saved. And I'll show you how this works, and then I will take Jock's question. So we go here, we go to home. Okay, so it's asking to create a picture. So I can say a cat eating a taco on the moon, because everything has to be on the moon now. Oops, a cat. Anyways, we'll see what it is. What will it think a cat is? Again, this stuff is fast, but it is weird. Like, what is speed? Come on, thing. There we go. There we go. So we got this. So this will just spit out for us. Prompt a cat eating a taco on the moon. So we get a cat, we get a taco, we get the moon. We also can come down here, and this is what's called the revised prompt. So this is our prompt, and then this is this whole paragraph that OpenAI creates for you to try to explain more what it thinks you want. What's kind of cool here is we can then go to search. So we do search. This will show us all the images I've already created before. So we have Ice Queen on a taco, and Ice King eating a taco, and King with a hot dog, and Prince riding a hot dog, eating a hot dog, and hot dog eating a hot dog, and dog running after a hot dog. I don't know, I'm kind of weird with this kind of stuff. Anyways, this shows us all this different stuff. And again, we've got that cat down here. And so again, if I want, I don't know, what if I just want pictures with a taco in it? I hit submit. And this will give me only the pictures with a taco in it. If I want pictures, you can go to home. I can do search, I'm sorry. If I want pictures with a king in it, I can do this. And again, it becomes interesting when you start doing search. So you're searching for king. So somewhere in here, there will be the words K, or the letters K-I-N-G all together. I'm not sure. But basically, that gives you that as an example. And so basically you're going to be able to create these images, they then get stored, and so again you can go and you can search for them later. Let's see, Jack, your hand was up. What's up, Jack?
So I got a question about this. When we set up the information, we get an image, and then the hour goes away.
Yep.
You mentioned before when we get data from OpenAI, sometimes it is good practice to cache it, and we can cache that information.
Yep.
Can we cache the revised prompt? I know we probably can't cache the image, but can we cache the revised prompt?
We're caching.
Save it for more than an hour?
Well, yeah, that's this project. We're caching everything. So basically, into the database, we store the prompt, we store the file name, we store the revised prompt, and then we're actually saving this image into a folder on our computer. So this is, if the internet died later today, I could still search for my tacos.
Okay. And then, I'll wait till the second question about that. So
yeah, so this,
cool. Thank you.
Yeah, so this is, just so you know, so this is the Dolly pics with some other images in there. So anyways, yeah, so all of these are actually being saved. So again, my root directory, I have this folder called Dolly pics, and so all of these images are actually being saved locally there. Cool. Let's see here. If you do have a question, raise your hand. I see some people asking questions in the chat. As I always try to say, this is actually his work. I know everybody likes to look at the professor and be like, oh, but it's actually work. So raise your hand if you have a question. If not, I will scan through the chat after the class is over, but I won't get to it till after the class is over. Okay, then the next thing. Again, always make sure to kill your thing. And so basically this is for, let's say you have your own pictures, right? Again, let's say you work for a company, you're in the HR department, the marketing department, whatever else, and you have a crap ton of pictures. And at this point, your pictures go back 24 years, right? Digital cameras, my first digital camera was in about 2002. So imagine marketing and everybody else that they've been taking, lots and lots and lots and lots of pictures. You've dumped it into a data store, and now what the hell are you going to do with it? Again, this is one of the big problems we have with data. We have so much data, but if it's not in a usable format, if it's not in an indexable format, it's basically kind of worthless. It's kind of like oil, right? Data is the new oil. But if the oil's 1,000 feet underground, who the hell cares? And you don't got a pipe to get to it. So basically what this does is it scans through a folder. So we actually have two scripts here. So the first script you actually have to run. Basically this goes through and it processes a folder, and it processes all of the images in a folder and sends it up to OpenAI. So OpenAI has a vision API component, so you can send it a picture and you can basically say, what the hell is this? Again, wherever the prompt is, yes, what's in this image, be as specific as possible, answer in up to 100 words, right? So you can give it a prompt, just like you give it prompt and other things, and it will run. Basically, I have a folder. I do believe I have that folder, the search pics. So in my main thing, I have search pics, and in here I have a whole bunch of pictures of different things. So the first thing that we do is we run this particular script, and it's going through and it's scanning, and as you can see, it's putting things in there. So it's going through. So this is the image name. The image depicts a bustling square with a prominent bell tower on the right, likely the Campanile di San Marco in Venice. So it's going through. It's actually processed all of those things. Now, once that's been processed, we can now go to the bottle script. So that's one of the things to be thinking about with these kind of scripts. And again, we talk about different services doing different things. So you try to run that scanning service within the bottle script itself. It might get a bit wonky because it does take a second. Let's say it takes 2-3 seconds to process each image. Well, let's say you dumped in 100 new images into a folder. So it's going to take 300 seconds for all of those to process if you actually send them up one after the other. So one of the things you have to kind of consider is basically how will that work in your program's flow. And so that's why I like with this is you have one script that does a search. So you could actually have this on just a continuous loop. So it could just be, it could loop, it could wait a minute, loop, wait a minute, loop, wait a minute. So whenever new images come, that can be running in the background and just grab them up. But it's kind of one of those things you have to think about. Let's see here. David, what's up?
Hey, so quick question. So each of these calls, like now you're uploading images to it.
Yep.
Are you using the same the same model for all of this, or for each one you have to use a different model?
Yeah, so with this one, I use model GPT-4o Mini. So basically, it depends on the service that you're using. Again, you go to OpenAI.com and take a look. The Vision service, I think, is only with 4o. DALL-E 2, like DALL-E 3 is only 4.0. I think DALL-E 2, you can use 3.5 or lower. You go there and you basically just read what they have to say about it. That's really
gotcha. Cool. Yeah. Thanks.
A lot of this stuff is, again, there's kind of this idea of like reinventing the wheel or recoding things. Again, what I'll tell you as a tech professional, you know what my job is? You want to know what 90% of my actual job is? Reading crap. Like why this is important. I know this whole whiteboard thing, again, especially for new people, probably seems like a pain in the ass. I'm just going on and on and on about it. But what you have to understand is, again, what you really do in the real world is you draw out what you want to have happen. This is the flow that's supposed to occur. And then you spend the next 2 months figuring out the configurations to make that flow occur, right? Because again, especially when you deal with Linux, right? Linux is just fucking config file, INI files, right? Either a configuration is set to the right setting or it's not. Right. Oh, Jack, what's up?
Going off the last question. So you said you had images from your digital cameras. If the image quality isn't that great, like say for instance you had from 2000s, but you upload images from the 90s and 2000 where image quality isn't that great, will the model make a difference then? So like again, cameras gotten better over the years, but if the frame, like the pixels and everything like that's kind of off a little bit, or you try to upload an original photo to like a digital one, it comes out a little blurry. Will the model make a distinction? Like the better model will be able to do a better distinction of what's in the background and what's in that picture?
Well, as far as I know, Vision right now, you can only use the 4.0 model. So again, with these different services, you can use different models. So 4.0, as far as I understand, Vision is the only thing. And then it's also just playing around with it and seeing what the answer is. One of the big issues we have nowadays with these LLMs is even the people running the LLMs don't necessarily understand how they work. And so it's one of those things is you have to test it with different prompts and see when you start getting stuff that's useful for
you. Okay, thank you.
Yep. That's the whole thing too. It's again, testing, user testing. And that's one of the big things too. Again, like, I'm going to get in trouble. I want to talk about real world for a second, right? But again, this is one of the reasons we get into these problems with DEI So again, I'm not getting, this isn't fucking YouTube. It's not YouTube. This is real world. This is one of the issues we get into with DEI, right? Diversity, equity, and inclusion. It's what you have to understand, especially with this kind of crap, right? Especially with AI, machine learning, horse crap, right? The reality is you play with this, and you play with this day after day after day after day after day, and you feed it different data, and you give it different prompts, and you futz with it 5 different ways from hell, right? Well, the issue is, again, I've talked about intent before, right? And bias, right? I've talked about my bias. My bias is towards decision makers. That's just how it is, right? If you want to be an employee bitching about your boss, that's fine. I'm not the person to bitch at your boss about. Anyways, right? We come at these things. And so one of the issues you go into, again, we talk about lived experience. We are going to test these systems based off of the problems that we recognize. Ergo, we are going to solve, or at least try to solve, the problems that we recognize. Ergo, if we don't recognize that there's a damn problem, we ain't even gonna think about trying to fix it, right? And so that's one of the big things. Again, like I say, with all this kind of testing stuff, and it's why you need your users to be testing these systems. It's why you need to be listening to your users, is to figure out what things trigger, how things trigger, what the response that you're getting back, is that response appropriate, how can you tweak the prompt, right? That's the kind of stuff to be thinking about. Because yeah, it's like I say, a lot of this stuff, if you actually listen to the people that have created these LLMs, it actually gets kind of horrifying when you realize, yeah, they don't necessarily completely understand what's going on either. So I did this, it processed all of those images. I can now go here to gallery search. So this is our bottle script. We run this. We go here to 1.7.0.0.1:8080. And so these are all of the images that have been processed, right? So these are the images. Venice trip, Italy trip, somebody that came to see me, me and Roxy, me and Peanut and the unicorn thing. That's just the classic. And so basically the cool thing here is now I can say like, okay, again, we're doing marketing for Silicon Dojo, and what we know is people like dogs. We need to get some dog pictures. So I can simply type in dog and I can do submit. And so I get 3 dog pictures. Again, this is where actually doing real search routines, there's more to it. This is a very simple search routine, because what you'll notice is this is here, and that's because this is the Doge's palace. So dog is in there, but it's not really what you're looking for. But anyways, right? So I can go here, and again, if I want pictures of, let's say, Venice, I do that, and it'll give me pictures of Venice. And the cool part about this is this was automatically done. So you saw it process through 30 images. It could literally sit there and process through 30,000 images. And basically the only difference is your database would be a wee bit bigger. So these are the projects I'm going to try to walk you through today. Before I try to walk you through these projects and probably lose my mind as I do, are there any questions up until this point? Any questions? No more questions. Okay, so let's take a look at this then. So this is our basic app. So go back to show you what the basic app is. This is where we go, and basically we can simply just ask it questions, right? So, right, OpenAI question, what is a cat? Hit submit, and it'll give me a response. Query, what is a cat? This is the response, so this is the most basic project here. Let me kill this thing, and we can go through and we can take a look at it. So again, this is bottle. So from the bottle module, we're going to import run, route, post, and request. Right, from OpenAI, we're going to import OpenAI. So this is my key. Don't steal my $5. This class will be a pain in the ass real quick if you do. Anyways, so in order to set your key, you can either set your key through the virtual environment, or through the environment variable, which is the way that you're supposed to do it. Again, trying to teach you folks with Windows and all kinds of different operating systems, I have to solidify how to teach that. So instead of doing the environment variable, which is the way that you should do, we're just plugging it here into the script itself, right? So client equals OpenAI API key equals single quotation marks, and then this is where you dump your OpenAI key in. Then going to create a header. So again, when you're using Bottle, there's something called templates. Templates are the more appropriate way of doing this, but it's also an entirely another step that makes everything a lot more complicated. So basically what I decided to do is just create a string for the header here, basically h1 OpenAI app, and then basically give the links. So a href goes back to root, which is called home. And so basically this is just so we have a reusable header up there to make our lives easier. We have a query function here. And then if we go down here, we have the index function, so at root, and then at post process, and of course run host localhost at 8080. So we go here basically to the route. So when we go to root, we're going to have a form. So basically the form is going to be a string. It's going to say action is to send it to process. So whatever information we have here, we're going to send it to the process. And then basically we're just having a text box. And then for the page, we're going to add that header that we had before, and then we're going to add the form at the bottom. So again, we can kind of have that crappy reusable header. Once you put in your query, that is going to come here to the process, right? So at post, so it's not route, post, process, index process. So query equals request.forms.get the value for query. So basically at that form, value for query, and that's how we get this variable value. Response is going to equal, we're going to send this to the AI function with what our query is. If we come up here to the AI function, basically all this is just the normal completion. So completion equals blah blah. Basically all this is copy and paste. Role for the system user, you are a helpful assistant. Role user, answer in 30 words or less. So this is where we're just putting a very simple injection in here just to keep these, not too verbose. And then role user, content, query. So basically whatever question that we ask, that's going to come in here. We then have these the completion that comes back. And so basically the value that we really care about is completion.choices 0 message content. So don't ask me why OpenAI did this with the new models. So these used to come back as JSON values, so you get the value out of JSON. This is actually a class. It comes back as something called a class, which is a different class. Anyways, in order to access values in a class, it looks like this, and so that's where you go for. Completion, choices, 0, message, content, response equals that, and so then we're going to return response. Basically, all we're then going to do is body equals query, and whatever the query was, break response, and whatever the response was, and then that is going to be printed out on the page, and we are going to return page, and that is all there is for this particular thing. Again, if we start looking at this from a system standpoint, basically, you have your form here, right? You have your form, asking what the query is. The data on this form gets sent to basically the process script. The process script grabs out the query value, sends it up to OpenAI, right? Basically gets a response back from OpenAI and then prints out, what the query was and then what the response was. And that's the squiggles for that, what that looks like. So this is the most simple of the projects with OpenAI. Any questions? Nope. Don't make me get my koosh ball. That's my $1 billion idea. I need to get a digital koosh ball. Anyways, okay, now we're going to go and we're going to do the injection project. It gets a little bit more complicated. Okay, so we run this again. It is running. Again, we do home. All right, so we have home and we have rules and we have the question, kind of like we had before, but now we have rules. If I go on here, we see we have these rules. Now the reason that these rules are still here, that they did not disappear, is I'm writing these to a text file. Again, that's one of the things you have to be thinking about whenever you create these projects is what is your data store going to be? Is it going to be a database? Is it going to be a text file? Is it just going to be session variables, right? It all matters. So anyways, by putting this into a text file, basically what it means is it's non-volatile. It will not disappear when we restart the server or whatever else. And home, what is a cat? And we can hit submit. Dude, a cat is a small furry animal that purrs, kind of like how pasta soothes the soul. Anyways, so let's take a look at this. So from bottle, we're going to need to import run, route, post, request, and redirect. Again, this is going to be one of the big pains in the ass, especially with bottle, is making sure you actually import every function that you need. Remember, in Python, you have to import the function to be able to use it. From OpenAI, import OpenAI, and then here's my API key. Again, please do not steal. We have the header. So again, having a header like this is kind of simple, or it makes it a lot easier just to be able to dump things in. OpenAI app, we now have a home link, and we have a rules link here that we can put in. We have the injection, we'll go into that. We have the query, basically what we had before. Let's see, the index. So this is the index as we did before. So basically all this is the form. Go to process, do query, the whole 9 yards. If we go down, again, process is the exact same thing as we did before. So basically we're going to do response equals AI query. Now if we go down to rules, so basically when we click on that rules page, right, we click on the rule, well, now it's down. When we click on the rules page, right, this is how we get this. So at the rules page, basically, so we're going to try with open rules.txt, we're going to read it as file equals file.read. So basically what we're going to do is we're going to open rules.txt file. This will be in our root directory, so my Eli directory. We're going to try to do it. If it fails, file is just going to simply be blank for the value there. But here we're just going to read out whatever is in there simply as a string. So whenever you do this, you're going to either bring it in as a string or bring it in as a list. So read lines means that every next line there will be a different index in a list, but we're just going to bring this in as a string. Body is then going to be, we're going to do an F string here. So form action equals process rules. So we want to save the rules. That's going to get sent to process rules. Method equals post. This is simply text area, but then the value we're going to put in the text area by default will be whatever came in from file. So that's, we open up whatever is in that file, we rules.txt, and then we basically put it here, and then we have a submit button page, we have header, and we have body. So we click on the submit, we go to process rules. That will then come here, and basically all we're doing here is rules equal request.forms.get rules. We're going to print them out just so I can see them. With open rules.txt, I'm now going to open this as W, so overwrite anything that was there before will be deleted as file, and then we're simply going to file write the rules that came in, and then I'm going to redirect us back to the rules. So I tippy-tap type out the rules, I hit submit, it gets processed, gets saved to that file. I'm then going to go back to the rules page. It will grab the information from that file, and it will show up. How we then do the injection is we come up here to the query. So basically the query looks a lot like what we had before, but now for user content we have injection rules. So we have this variable name, and so the value is going to go in there. How we get those rules is by triggering the injection function. The injection function is basically try with open rules.txt read as file equals file.read, except if for some reason this doesn't work, file equals nothing, and return file. So all we're going to do is we're going to open up that file, all of the text within that file, we're going to return that, and then that is going to be assigned to the value of injection rules, and that is what's going to give us our rules for this particular project. So again, if we kind of map out the idea here, again, pretty simple, right? So you click on the rules, that will send you to the page that has the rules on it. When this page opens, it is going to read from the rules.txt file and bring that and basically populate the text area with what's ever in the rules.txt file. I can modify what's here. I can then hit the submit button. When I do, it will send the information to the process file. What the process file will do is it will write all of this information to the rules.txt file, and then what it'll simply do is redirect me back to this page. This page will then read from the rules.txt file, and that's how we get the differences. Right? When we do the OpenAI call, basically all that's going to happen is that we're going to have a function that's going to look to the rules.txt file. It's going to turn those values into a variable value, and then that is going to be the injection that goes into our little chat completion right there. Make sense? Sure. No. Who knows? Okay. Oh, now we're going to go to memory. Oh, this gets even more fun. Because now we get the database involved, right? So one of the things is, again, when you're thinking about data stores, text files are really nice because there's no administrative overhead. You write to it, you read from it, done. Can't screw that one up very much. But the issue is you can't do a lot with it, right? It is a data file. You can do parsing. We're going to do a class on regex, but God help you, it's a pain in the ass to deal with for any number of reasons. So one of the things you can do is you can add SQLite. And so SQLite is a database engine that we've been using. And basically, as I say, it is basically the administrative overhead of a text file with the power of a relational database. So we can now create database tables. We can save into the database. We can do select. We can do SQL statements from that database to be able to pull information out. So with this one, when we run the memory, we come here, again we do home, and we can see what our memory is. So what is a cat? How big is a cat? I always want you to say dude. And basically all this is getting pulled out of the database. Okay, so let's take a look at this. So from bottle, run route post request. Oops, I don't think I need redirect. It's there. I don't think I actually need it. If you see something grayed out, it means it's not called later in the script. So I may remove that later. We're going to import OpenAI as we've done before, and we also need to import SQLite 3. Do need to make sure that 3 is on the end. OpenAI, we put our API key in, and then we have the header. OpenAI, the OpenAI app, and home, and the memory link. Then we have, this is something we're going to get to in a second. So we have a function for creating the database. So one of the things that I like about SQLite is, again, incredibly easy to administer. Simply calling a database creates the database, right? Again, if you're used to Postgres or MySQL, there's a whole bunch of stuff you have to go into. With this, if you call a database is there. The other thing you can do is create table if it doesn't exist. And so what this function does is basically it creates the database if it doesn't exist. And then we create the table that we need, and we go from there. We have other functions here for inserting, for fetching, for the injection, for the AI, for route. But what you'll notice down here is that I actually call that db create function right before run. So basically when this script, when all of this loads up, right, it's going to go through, it's going to look at all these functions and everything. It'll come down here, it'll trigger this, which will actually create the database, create the table, and then it will run so that it's accessible. So do make sure that you create the database down there if you're doing this. What's up, Jack?
I may be on the wrong one because I'm in the GitHub and I see we're doing coding, building AI web apps. I see search process, search PY, basic injection of memory, but the code is different. I'm looking, I think. Maybe I'm in the wrong one. Which one did you just go over?
Jesus. I am in OpenAI memory. That's what I'm in now. I'm supposed to be in now. I think that's what I'm in. Yeah, because I got to create. Yeah, I'm in OpenAI memory. Don't know where you're at.
Oh, coding DIY.
DIY build AI web apps with OpenAI API.
Okay, building network monitors. Nope, not that one. Yeah, I thought I was in the right one. Okay, I guess I'm lost. All right, let me try to find out where you are.
Yes.
Because the code only goes to 94 lines of code, and I was like, wait a minute, what? Jeez.
And it goes 115 here. Yeah, I don't know. So yeah. So these will always be named based off of whatever's in Meetup, because to make life easier for everybody. Yeah, so DIY, build AI web apps with OpenAI. Yeah, OpenAI-memory.py. I don't know. That's what's up though. That's what I got.
Okay.
Yep. Right. I gotta do a refresh. Didn't lose my. Yeah, I got 115 lines of code. I don't know. Do not know. Okay, so we create the database. So go through, and again, you got to make sure that you actually call to create the database. We're going to come down here. Basically, the route for root is, I think, the same as we did before. Send it to process, post, basically what your question is, put the header in, put the form in, that's it. We then go to process, so post. So again, it's not route, it's post. And then we come down here. So query equals request.forms.get. What is the query? So that's value coming in. We're then going to go to AI for the query. All right, so basically we're going to go up here. And this is where things get a little bit confusing. Again, as I've talked about before, in order to understand one thing in technology, you kind of got to start over here, go up here, go down there, and then you understand this. Anyways, so we have injection rules here. So basically what the injection rules are going to be is we're going to create a string off of the value that comes back from db underscore injection. So what this is we're going to go to the database. We're going to go to the database, all right, the memory DB, and we're going to do a query. Select query, so basically that's just the question. Select query from memory where query like, and then it's double quotation marks, percentage, I want you percentage. So like is how you do wildcards. So basically what it's going to do is it's going to search, and it's going to search for any queries that have the I want you in them. It's going to basically return that back as a list of all of these values. And so those are going to be the injections. I want you to answer in 50 words or less. I want you to always say, dude. I want you to always relate this back to pasta. I want you blah, blah, blah. And so basically this is going to return. When this comes back, it's going to be a list. So we have to turn it into a string. And basically all I'm doing here is this is very ugly. There's probably a better way of doing it. I'm just turning it into a string. Right, the brackets and all that horse crap OpenAI gets to deal with. And basically, then what's going to happen is you're going to send that string as your injection, your rules, your injection, and then you're going to send the query. So I want you to always do it 50 words. I always want you to say dude. I always want it to be related to pasta. And then here's my question. So that's going to go, and then we're going to get our response back. So we come back from the AI. We get our response, and then, so response is going to be that. So then we're going to do db insert. So we're going to do the db insert function. We're going to insert our query and the response. All right, so we go up here to db insert. Again, query, so the question that was asked, and the response, kind of connect to this database. Insert into memory, query, so this is the column name, response, column name, values, question mark, and you put query and response here. So you do this so you do not get SQL injection attacks, supposedly. Basically, by doing it this way, it's done different programmatically. So anyways, we're going to insert into, we're going to commit, and then we're going to close. We're going to print out on the screen that those two things were added. The body is going to be the query, and the response, page, blase, blase. Then for the memory part, for the memory page, we can simply have this route for memory. And so this is going to show us what our memory is, right? What do we remember? So response equals db fetch. db fetch, if we come up here, again, we're going to connect to our database, and we're simply going to say select all from memory. So there's a memory table in the memory database. We're going to return all of that, here. And basically, we're going to create a table, and then we're going to loop through. for value in response. So response is everything that came back, for value in response. Body equals whatever has been in body before. And then we create these frickin' table rows. So we open the table here, and we close the table here. Then we open a table row, we open a table cell, value 0, so value 0 coming back will be queried, what the query is, close the cell, open the cell, value 1 is going to be what the response was, close the cell, close the row, you're going to loop through until you're finished, then you're going to close the entire table, that will be body, and we have header, and we have body, and that's basically what we're looking at there. So again, if we take a look at this, from the kind of architectural standpoint, again, so you're going to have your page with your query on it. So I'm going to make the query. I'm going to plug in whatever I want to plug in. I'm going to hit the submit button. When I hit the submit button, the process script is going to fire off. And when the process script fires off, it is then going to go to the AI function. The AI function is then going to call the injection function. The injection function is going to look through our database table, and it's going to find anything that says, I want you, right? Whatever says, I want you. All of those values are going to be sent back to AI. Those are going to be used as the injection and the completion. The AI script is then going to send the response to all of that back to process. Process is then going to insert that into the database. And that's what you got. Then when you want to go to the memory page, you have the memory page there, and then basically what that's going to do is it's going to go to the database table. It's going to read everything that's in the database table, and then it's going to create a table for you on that page to show you what the memory is. Feeling good? Okay. Questions? Any questions on that? Only got 2 more projects to go, I swear. If there's no more questions. You pressed arrow in a closed function. Not sure what that means. Okay. Now we're going to go to the gallery. So again, what the gallery is, if we start this one up, and we go, and we click on home. Okay, so create a picture. Oh, a taco riding a hamburger. We hit submit. There you go. So it's going to show us. So this is the prompt. This is the prompt that I put in. So a taco riding a hamburger. So anyways, so there we go. Yeah. So we got the image there. So we have the prompt, we have the image that got created, and then we have down here the revised prompt. And again, I find this to be an interesting thing with how OpenAI is doing things now, is basically they're taking these few words and they're trying to flesh that out into a bigger story. Why this is valuable is, again, remember, with any kind of data, we need to be able to index off of it. Again, if we're going to find it, if we're going to point to it, whatever else, the image, I can't do much with, right? I can embed it, I can do a couple other things, but there's actually not much I can do with just the image itself. When I have these words are things that I can trigger events off of. So that's why it becomes useful. If I go to search then, the nice part about this, right, is everything automatically gets downloaded, right? So I just asked for this, and so this actually got downloaded. So the image is downloaded to my computer, and this information is stored in the database so that I can then come up here and do a search for tacos and do a submit, and that'll show me all the images that have tacos in it, which is actually quite a few images. So I don't know. Let me do another search again. How many images have a cat in it? No, that's not right. Anyways, again, not the best search algorithm here because it's just looking for CAT. So anyways, it shows us the cat or whatever else. If we do search for royal will show us all the royal people eating food. So we have an ice king, a king, and a prince, right? So anyways, it gives us those search routines. So we can go through and take a look at this. Okay, so Dolly. Okay, yeah, starts getting longer. From bottle, import, run, route, post, request, and static file. So this is one of the big things to be thinking about whenever you're dealing with bottle, or actually any of these Python web scripting languages, or web app scripting languages. So whether you're dealing with bottle, whether you're dealing with Django, whether you're dealing with Flask, again, architecture. Remember, whenever you're dealing with computer systems, the more things that system can do, the more vulnerabilities it has, right? So again, back in the day, I got my MCSE back in 2000, a computer, one server was very, very expensive. And so we dumped every damn thing into that server. It was your Active Directory server. It was your SharePoint server. It was your IIS server. It was your routing and remote access server. It was your file server. It was your email server. There used to be something called Windows Small Business Server, which, to be clear, for 2000 was a fabulous product. For 2024, it'd be a piece of garbage. But the idea was, hey, if you're going to spend a lot of money on a server, you might as well shove as much crap into it as possible. The issue is this creates an incredibly vulnerable server because your file server has vulnerabilities. Your IIS server has vulnerabilities. Your Active Directory server has vulnerability. All of these things have vulnerabilities, and then they start adding up. Plus vulnerability, plus vulnerability, plus vulnerability, plus vulnerability, plus vulnerability. And so the issue is somebody could come in through, let's say, your FTP server, your file server, and from that, they might be able to compromise your email server, and then be able to compromise the Active Directory component, and then everything kind of goes to hell. And so the modern world, again, we talk about the modern world, post 2010, basically everything got a lot less expensive. So again, we have virtualization and infrastructure as a service. So nowadays, instead of buying one $20,000 server, for most of us, instead of buying one $20,000 server, you can spin up instances. And even if you do have a $20,000 server, on that $20,000 server, you can have 20 different instances. And so you can have an instance for Active Directory, an instance for file, an instance for email, an instance for VPN. And then if somebody compromises the VPN server, supposedly the rest of it should be relatively secure. Why this is important with static files is, so when you deal with the Apache web server, it's in the old days of Apache. Basically, all the files are just files. And one of the interesting things you could do is you could use something like FTP. And you used to be able to go in and actually get an entire directory listing of all the files on a server. So even an enterprise, CNN.com, whatever else, you'd simply put an FTP : CNN.com, and then you could literally sit there and take a look at all the files. And if any of these files had little vulnerabilities or problems, you could try to use those to attack the CNN server. So what they realized is putting everything on one box is a bad idea. And so, again, if you're gonna put this into a production environment, again, depending on your definition of production, really what you want to have happen is you want your bottle server to be here. So your bottle server, that's going to do all the if-else statements, try or whatever else. And then over here, theoretically, you're supposed to have something like your AWS bucket. And the AWS bucket, that's going to have all your files in it. So your AWS bucket basically has no functionality. It doesn't do VPN services, doesn't do email services, doesn't do anything else. So there's no vulnerability there. So the idea is your bottle app is able to go to the AWS bucket and present that to your end user, and so you don't have as many vulnerabilities. Of course, that's a whole bunch more drawing stuff out on a whiteboard that you may want. And so one of the things that you can do with Django, with Bottle, with the other things, is basically use the static file function. And so what the static file function does is it allows you to present static files from the server that's running Bottle for whatever it is that you want. So if you want a style sheet, so you're going to have style.css and you actually want that style sheet, you need to use a static file function. again, these images that we're using, whether we're going to be, it's not necessarily to save it, but to present it, again, to be able to embed images or whatever else, you're going to need to use a static file function. So that's why it's there, and that's why it's important. OpenAI as before, requests, whatever, import date time. I use this as a crappy way to create file names. Again, one of the weird things you run into, remember, in the technology world, nothing is magic. You always have to do everything. And so one of the things is when you save a file onto your computer, you have to figure out what the hell you're going to call that damn thing. Because remember, especially if everything is getting dumped into a data store, you can't have files with the same name. Everything has to have an individual name. So one of the things you're going to have to figure out is what the hell you're going to name these things. I just like using the datetime function because, I don't know, it's easy. It works for me. I use this timestamp. Again, especially if you're not hammering the hell out of your server, right? Transactions are just coming in when they do. Use a nice little, Unix timestamp or whatever else. It's an easy way to name files. Anyways, let's see here. Oops, that's different. Anyways, we have a picture directory. So the pic directory is going to equal $e underscore pics. So I'm not doing anything else. So that is going to be in my root directory. Try, so I'm going to do try os.make directory. So I'll make the directory. If it already exists, we'll do an accept. We'll do pass. I thought I modified that. This is actually the better way to do it. But anyways, we'll talk about that later. So basically all this is doing is it'll try to use the OS make directory function to create that directory. If it already exists, it'll pass, no big deal. And we have the OpenAI key as we had before. Then we have here for the header, we have home and we have search to give us the search function. Again, we have the create the database. So we have gallery DB, create table if doesn't exist, gallery, prompt, revised prompt, file name. So basically the prompt that's going to go in, the revised prompt that we're going to get back from OpenAI, and the file name that we're going to create. So that will be the table that all this information will get stored in. And if you come all the way down, you'll see I run this function here. So db create the function, and then we run localhost at port 8080. Let's see here. Let's come up to route. So this is the same as we've had before. So basically, you're just going to make your request, you're going to make your query, and it's going to go to process. You're going to come down here to post process. We're going to get the value for query. It's going to come in, right? Response equals AI query. So this is now going to be the DALL-E query. So we're going to come up here to the DALL-E query, right? So the query comes in. So the query comes in here. And so response equals client images generate. So this is model DALL-E, I'm sorry. So it's model DALL-E 3. So you can do DALL-E 2 or DALL-E 3. Prompt. So basically the question that we're asking, and then we're going to do the size. So again, there's like 3 different sizes I showed you in a different class. Just do a Google search on what those sizes are. Quality, what is the quality that you want? So we're simply going to do standard. And then number. So this is an important one. N equals 1 means you will get 1 image back. Remember, each one of these images costs about 4 cents. So if you put 10 in here, it'll cost you 10 cents every time you fire off this function. So definitely do be careful with that. Then we're going to come down here. So image URL equals response data 0.url. So we're going to get this response value back. This is going to be a class. So to get the URL of where this image is located, this is where it's located. Revised prompt. So response.data 0 revised prompt. We're going to get that for revised prompt, and then we're going to print out response just so we can see what's going on. Then we're going to return the image URL and the revised prompt. So we send in the query, we get the URL, and we get the prompt back. Oh, we come down here, and then file name equals download response 0. So response 0 is the URL, right? So the response comes back here. 0 index is URL. 1 is revised prompt. So file name, we're going to send this up to the download function, and this is the download function. So the URL is going to come in here. And so here's my crappy ass file name. So again, how you create file names, up to you. This is my garbage way of doing it. So datetime.now, will give me the current timestamp, but it's an F string, so I have to turn that into a string. So as it is now, it comes back as a time value. So I turn that into a string, and then I add a .png at the end of it, because when you're dealing with these files from OpenAI, they're .png. So file name equals the current time .png. File underscore response equals request.get the URL. So the URL that came in, we're going to get that. File path, so we need a path to where to save this damn thing. os.path.join, the picture directory that we had before, that dolly picture, whatever, comma, file name. So why we use this is depending upon the operating system that we're using, right? Windows uses backslashes, Mac, Unix-ish operating systems use forward slashes. So if I actually just simply wrote in a string here, /blah/, if I tried to run this on a Windows system, it would fail because Windows doesn't like forward slashes. So what this join function does is it basically creates this file path based off of the operating system that you're dealing with. Then we're going to simply do with open file path. So whatever that file path is, so dolly pictures with the file name that we created, we're going to open that up, WB. So basically this is for when we are writing files. So we normally do W or R or A, that's text. You put a B on there, and that's for files. So image files, whatever else, as file. File.write, so file response dot content. So the content that we get from the response is going to be saved as whatever the hell this PNG file name is, and then we're going to return what the file name is. So basically, we now have the file name, we now have the query, and we now have or the prompt, and we now have the revised prompt. So we're going to do db insert query response 1 and file name. So the original query, the revised, and the file name is on the insert. So that's where we go up here to insert. Again, prompt, revised prompt, file name. We're going to open gallery DB, insert into gallery, prompt, revised prompt, file name, values, question, prompt, revised prompt, file name, commit, and close. And then it'll say those are added. That'll get printed out onto the screen. Oh, and then we're going to come down here, and body equals. So this is simply going to be what the query is. This is going to embed the image, so response 0. It'll embed the image, and then it will embed the what the revised prompt is, and that's what will show up on that first screen. When we go to search, so basically when we click on that search, all that's going to happen here is we're going to create the form, process, search, post, so whatever question is. Response, when we first open this thing up, response is going to equal db search, and basically single quotation mark space single quotation mark. So we're going to go to the search function here, and basically what we're doing here is we're grabbing everything. So we're going to do a search where basically anything has a space in it, and we're going to return all that back, and so that's going to show us all of the images on the page. So for record, so the search response is going to come back. Gallery, so div style, vertical align top. So why we do vertical align top is so this gets aligned to the top. And again, this is where we talk about all these different languages coming together to give us a damn finished product. So if you don't use CSS to align to the top, they'll actually align to the bottom. So basically, this picture is up here, and basically the text, it would be aligning based off of the text on the bottom. So we have to use CSS to lift this crap up. So basically for record, so all the values that come back, we're going to do gallery, so that aligns the top, add to gallery, div style, inline block, so inline block, make sure they're side by side, again with CSS, this is basically how the page gets designed, so inline block puts them side by side. If you don't do that, they'll put them underneath each other. Let's see here, vertical align top, so gallery record 0, which is the original query. Then we're going to embed. I thought I modified that. Anyways, this is not how you're supposed to do it. I thought that was modified. Anyways, so picture directory record 2. So that's basically where the image comes from. We're embedding the image. And then we're doing record 1, which is the revised prompt. We're closing out the div. We're closing out all the div. And then we're putting that up on the page. We have the static route here. So again, for Dolly Pics, this is where whenever it goes to look for any of the images in Dolly Pics, you have to have this route. So route, send static file name. So the file name that comes in, return static file name root is Dolly Pics. And basically this is one of the things that you need in order to have those static files function. I see a couple of quirks in my code, personally. I don't know if you folks see any of it, but that is the basic idea with that particular script. Are there any questions? Jock! Of course there's a question. Come on, we gotta have more questions than just Jock. What's up, Jock?
I guess because everybody's smarter than me. For line 119, when you said... yeah, with the big directory.
Yep.
Should we change that now or just leave it as is and try to run it and see what happens?
If you're using an X, so if you're using Mac or you're using Linux, that'll work. If not, like I said, I thought I modified it. It should be \. Are you using Windows?
I'm using a Mac.
Oh, yeah, that should work fine for you. If you're using Mac, because this actually works. So again, everything is actually functioning on a Mac. So if you've got a Mac, this all works. I'm just realizing for some of my Windows people, there's some of these modifications that I need to make. Yeah. Cool. Yeah, again, like I say, this is the whole thing, like with testing, but like this is the perfect example here. Right? This isn't skin color, this isn't genitals, right? This is just simply, I'm on a Mac, ergo, when I tested it, it worked. I don't have a problem. Anyways, again, test. Okay, so that is that, and then we will get to the pictures. Okay, so basically with this, again, we can run this, and basically this will go through a folder. So I have a folder on my computer, search pics, and basically in this folder are all of these different images, right? So basically I just went to, my iPictures or whatever, dump some in here, and again, got a whole bunch of different random pictures. So basically, we have the first script here, and what this first script does is it finds all of the pictures in that folder and then tries to process them. So if there isn't a value for it already, it tries to process them, it dumps the information into a database, and then once that information is in the database, we can run the bottle script, and when we run the bottle script, we can now search for things, right? So these are all of the images with all of the revised prompts. And again, as I said, if I want something like a dog, I can simply search for any of the pictures that have a dog in it. And again, search things. We have Doge here, but again, you kind of get the point on how that works. So let's take a look at this. So the first thing is the search, or the processing. So again, one of the things you have to be thinking about whenever you're building your projects is what is the flow going to look like? So one of the things with Python, most of the time with Python, is basically it stops, right? So other programming languages don't. Basically, other programming languages, you can fire off like 5 tasks at the same time, and then they'll complete in whatever order they complete in, and it doesn't really matter. As long as all the tasks complete at some point in time, the language doesn't care. Python can be a bit of a pain in the ass, because again, how you do it the standard way that you do it is you have step 1, that goes to step 2, goes to step 3, goes to step 4, goes to step 5. Now here's the thing, if it takes a fraction of a second for step 1, a fraction of a second for step 2, and it's a fraction of a second for step 3, then it doesn't matter, especially if you've got a bottle web app. Again, if you're doing search queries or a little bit of cleanup and you're having that function, fire off here, it's no big deal. But again, when we're doing this requesting information from OpenAI, that takes about 3 seconds apiece. So if, all of a sudden when 4 gets triggered, now it's 3 seconds. So in order to get to 5, you have to wait 3 seconds for this process to finish before you go to 5, right? That can make your application a little janky. Well, what happens if it's 3 times 500? Now you're waiting 1,500 seconds before you can move on to step 5, and everything kind of goes to hell. And so that's why with this particular project, we have the model script here, and then we have the processing script here, and they don't meet. They're not connected. And the other nice part about this too, again, if this was on some kind of production system, you could have the process script on a loop. So basically, it could be looping. Like it could loop. It could fire off. It could wait a minute and then fire off again. Wait a minute. Fire off again. Wait a minute. So if anybody put a new image in, then it's constantly updating over here. And then as you're using the bottle app, your bottle app will be updated as the processing app updates things. Okay. Let's see. So you'll notice there's a lot of stuff that's not here at this point that's kind of interesting. We actually don't have the OpenAI module. It's kind of weird with the whole vision, and that's where you have to go and you have to read the documentation, because even their documentation doesn't make a lot of sense. Like, well, wait a minute, right? We're processing using OpenAI, so wouldn't we need the OpenAI thing? And it's like, no, you actually don't. You feed it the API key. You got this nasty ass thing, but otherwise you don't need the OpenAI module, which again is just weird. Like, why? I don't know. It's how they built it. It's literally how they built it. David, what's up?
I'm sorry. I'm not sure I understood where you said that bottle is running a separate process from it was 2 separate processes running. I'm not sure I understand what you mean.
Okay, so this gallery search process script right here is its own script. And then this is the bottle script, which will actually give us the web page we're able to search for things.
Okay, gotcha.
So if I had a normal server, this is a weird ass setup. If I had a normal server, I could basically have this on a continuously loop, constantly updating, and also have this running so that as a user comes in, as new images are added into that folder, they'll get processed, and then I, as the user, whatever is then in the database, I am able to see it in near real time.
Understood. Thanks.
Cool. Yep. And Jock's hand went down. Okay. Yeah. Now it's important to understand all that, because it's how all this stuff kind of comes together. It's the stack. It's a stack. So again, why do we not have OpenAI? Who the hell knows? Import requests. Import SQLite 3, import OS, and import base 64. So the base 64, what this is going to allow us to do is this is going to allow us to upload a whole file up to OpenAI. Again, that's kind of one of the things that you have to be thinking about with your design of these systems. So this isn't just OpenAI, it's Azure, a lot of them want URLs, right? So basically, whether it's OpenAI or whether it's Azure, and they've got their little vision system, when you write the script, what they really just want is a URL. So they want your image up on some publicly accessible web server, and they want that nice little URL. So you feed them the URL, they go, they take a look at it, and they give you information about it. Notice a bit of a problem with this though. Literally, what that means is this has to be up on, Apache server, Nginx server, something like that. And these images, for at least some length of time, they want them to be publicly available. Which, no, we're just not going to do. I don't know if I trust OpenAI, but I sure as crap don't trust that. And so that's where we use base 64. And so with base 64, what we're going to do is we're going to take the file itself. We're not going to make it web accessible, and we're basically just going to be uploading it, much like FTP or whatever else. Pick directory, so we're going to do a search picks this time. And again, this os.make directory is a better way of doing things. So here I have this try os make directory, if it already exists, pass, which is a way that works. This is a better way. This is the more professional way of doing it. What you should do is os make directory, again, the directory name. If it exists, basically, it exists, okay, equals true, means if it already exists, don't fail out, do not error out. So that's the proper way of doing it. And again, this is one of the big issues that you get into with coding, is, as I say, there's 20 ways to skin a cat. And so that's one of the frustrating things, is there's 5 different ways to do anything. And so that's where, again, in your environment, you're going to have to figure out what are the standards for your company. Okay, Jock, what's up?
You said we're going to do this without using base 64 without making it a web page. I'm like, did I understand that right? We're still sending it to OpenAI, but we're not sending it as a URL. Am I understanding the way is that right?
Yeah, so basically you can send. So what they really want is, I don't know, cat. No, damn it, not cat. Like what? I want a cat. What they want, right? If I go to Wikipedia and click on a cat, right? So if you look up here, Wikipedia, WikiCat, and it's cat August 2010.jpg. So this is a web accessible image. This is the URL. And so basically what they want is essentially this. They want a web accessible image that you just give them a URL to. They can go take a look at it and then give you the result. I don't want to do that. What I want to do is I want to take my image, I want to send it to them, I want to get the result back. And I never want to make it, it's not going, for me, it's not going to be publicly addressable.
Couldn't you just change it from like you said, they do PNG, change it to a different a different file, like a JPEG or something else, or whatever else? Could you just do that instead, or not? They still would be able to access it that way.
Yeah, so it's still web accessible, whether it's PNG or JPEG or GIF or whatever else. I don't want it to be web accessible. So again, if these are pictures of my family, if these are pictures of my company, these pictures might theoretically have some kind of proprietary information in them. I don't want to make it web accessible so anybody on the internet can possibly scrape the damn things.
And 64 kind of blocks that by blocking the server in a sense?
No, because you're uploading the file. So basically, essentially think about it this way. You're doing FTP, sort of FTP. Anyways, you're sending the file up and getting the response back. You're not putting it on a full-fledged web server somewhere.
Okay, I gotcha. I see. Thanks.
Cool. Yeah. And so again, that's the kind of thing that you have to be thinking about for your customers and all that. Okay, so database equals gallery-search.db. We have my API key. We have the header, so home and search, as we've done before. And we're going to come down here. So we do the DB create. So we have the database create table if it doesn't exist, gallery, file name, and the description. So we have that. And then we come down here. So contents, so we're going to do contents equals os.list directory from the pick directory. So basically everything that's in the search picks, all of those values will be turned into values in a list, and that will be assigned to contents. Then what we're going to do here, pretty simple actually. So for pick in contents, so any of the pictures in the contents, if db search for pick equals basically a blank list. So the idea here is we're going to go up and we're going to search the database. Because one of the things that we do not want to do is we do not want to pay to answer questions that we have already paid to answer, right? So if we already have information in the database, the last damn thing we want to do is simply overwrite the information that's already there and pay a fraction of a penny for that. So what's going to happen is we're going to send the file name. We're going to connect to the database, select all from gallery where file name equals basically the file name coming in. So we're going to get the list. We're going to get all the file names in the list. We're then going to search the database to see if the file name is already in the database. If the file name isn't in the database, then we will continue and we'll process it. If it already is in the database, it's already there, so we don't need to process it. So basically, if the results that come back are blank, try description equals AI pick, right? So we take that picture name, we come up to the AI function. So AI file name, and so here's where we're doing the join. Again, this is the proper way to do it. File name equals os.path.join, the picture directory and the file name, with open file name RB, right? So this is the full path to the file. We're doing the bits, right? So basically we're dealing with the file itself as image file. Then we're going to do base64 equals base64.b64 encode image file read decode UTF-8. And so basically, this is what turns it into an object that we can then send up to OpenAI. Then again, most of the stuff in here is very copy and paste. Headers equals application JSON. You need to put your API key. So this is where the API key goes in. The model payload equals. So this is where you put the model in. So again, copy paste is GPT-4o mini. Again, I don't know what models you can use. You can do some search on that. Role user content. So basically, this is all copy paste from them. So type text. This is what I put in my prompt. So what's in this image? Be as specific as possible. Answer in up to 100 words. And then we have here, we have the image URL. So image URL, image, JPEG, base64. And then this is where we're feeding it that base64 object that we created up here. And again, to be clear with all of this, copy, paste, copy, paste. Modify a tiny bit. So if you're wondering why most of this is there, it's because they tell you to. They do have this max tokens here for, I guess, depending on how much information you want. You can limit how many tokens are being used. Again, default was 300. 300 seems to work. Response equals request.post. Basically, this is that OpenAI chat completions that we created with the headers and the JSON payload. Response equals response.json. So we get the response back. We turn it into a JSON value. And again, this is weird because this is a copy paste. And what you'll notice here is we're back to JSON, right? So the other times when we were using OpenAI, we were using class. So something dot something bracket 0 dot something. For whatever reason, here they allow you to use JSON. Why? I don't know. So anyways, response comes back as JSON. So response equals, what we really care about is response at choices, at 0, at message, at content. So that is where we're going to get the description of what the hell this image is, and we're going to return that. Then we're going to come, so description is what we're going to get back. So then we're going to do DB insert, the picture name, and the description. If we come to DB insert, basically we can take a look at this. Again, oops. DB insert. So file name description, we're going to connect to the database, insert into gallery, file name description, values, question mark, file name description, and that inserts it in. One of the things here is we do have this try except. We have these if else, so try except. So one of the things is when we go through and we list everything in that directory, there's going to be other crap in that directory other than images. Right? There's another folder in that directory. There's some hidden files in that directory. There's some other garbage there. Basically, what we're doing try here is what's going to happen is it's going to try to upload the image and get it to be processed. If that whole process fails for whatever reason, it's going to simply pass and go on to the next thing. To be clear, there's probably a technically better way of doing this. But this works pretty well, and it's pretty simple. So that's where we're going to leave it here. Essentially, if OpenAI is not able to process the image, it will fail out, and then it'll simply pass, and it should just simply go on to the next image. And so this is what dumps everything into our database. And if we go to gallery search.db, just to show you, SQLite 3 gallery-search.db. Where here I can do .tables. This will show me the table. So I have gallery. So I can do select all from gallery. And then you get all of, right? So unicorn. So this is the image name, unicorn. And then the image shows a man wearing a light blue unicorn thing. Image name is IMG 514 or 5146 JPEG. The image showcase is a waterfront view. Blase, 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 blase. So that's all in the database. Jock, what's up?
For you said if it fails out,
Yeah.
if OpenAI can't read an image and can't give a description, will it necessarily say in the so in the code we have it pass, but will OpenAI say why it can't read the image, or just we'll give the word pass because that's what we wrote in the code?
So it doesn't give the word pass; it just passes. So again, anything you wanted to do, you got to write it in there. Again, I'm trying to keep this crap as simple as possible. So basically, if this fails for whatever reason, so it's not an actual image file, it'll simply fail. It'll pass, and so the script will just keep running.
Okay. Second question, I wrote it in the chat, but what is UTF-8?
UTF-8. Well, whenever I talk about ASCII, I'm not really talking about ASCII, I'm talking about UTF-8. It is text encoding format. So it's encoding format, right? Is it text and format? Anyways, it's encoding format. With any of these kind of data files, when you get much deeper into all this crap, how the files get encoded uses different formats. And so UTF-8, I think, is actually now the current standard. So it's just that. You can ask ChatGPT, it'll give you a good answer. Again, with this kind of thing right here, just so you all know, again, very much of this is copy and paste. I mean, again, I get the basic idea of what's going on here, but why you do each specific thing, I'm not specifically sure on that. Anytime you're dealing with uploading a file, though, this is what you're going to be dealing with. Oh, Unicode. Yeah, it's that whole thing. It's like, here's a problem, though, just so you understand my position. Right? Okay, you're a tech professional. You've been doing this shit for 20 years. Oh, ha. Yeah, no, but how much stuff do you feel very confident about? Now imagine a noob literally asking you to dissect that thing. Right? How many things do you like? You don't even think about it. And then somebody comes up to you and say, "Yeah, but seriously, but let's explain UTF a little." Like, oh my God, I mean, it's an encoding format. I mean, it's kind of the default standard now that we all use. Anyways, imposter. You're not an imposter if you know you're dumb. I don't know. Okay, so now all that crap has been dumped into the database. Now we can run the bottle script. So again, if we run the bottle script, that is what's going to get us, again, to actually being shown now. So the processing script is completely different than the bottle script. Okay, so for this, from bottle, import run, route, post, request, and static file, import SQLite 3, and import OS. Again, you will notice there is no OpenAI here, because there is no OpenAI here. OpenAI was used on the processing script. It's not used on this particular script. Pick directory is search picks, make directory, pick directory. If it exists, that's okay. Database equals, this is the database. The header, we're just going to have home this time. Again, we're going to create the database if it doesn't exist. So if this is all empty and I run this, it'll automatically create the folder, it'll automatically create the database, and basically I won't get any results back because there's nothing there. Let's see here. Again, down here, we create the database and then we run everything. It's a little bit simpler. So the index, as we've done before. So the form, so this is the search form. Again, query, send it to search. And then what we're going to do here is going to say response equals db underscore search. And basically single quotation mark space, single quotation mark. So basically it's going to bring back all the results. You go up to db search and it's going to look like what we were dealing with before. So we're going to connect to the database. That is query here. Query equals percent, query percent. We have select all from gallery where description like question mark query. I think I did that differently in the last one. Anyways, we're going to fetch all. We're going to return everything back. So basically, we're going to return all responses back here. File name equals OS path join, picture directory record 0, so the file name that comes in. And basically, we're simply embedding the images. So gallery, as we had before, display inline block, 300 pixels, vertical aligned at the top. The image style will be width of 100% with the file name. And then underneath will be the description for record 1. We're going to close the div. We're going to do the gallery, and we're going to close that out, and then we're going to return the page back. If we click on search, basically here, so if you do a search, query equals request.forms.get, the query, response equals db search query, so that question that you made, it will go up to here. Again, the query comes in, and basically select all from gallery where description is like, basically what that query is. We're going to fetch all the results back. And then we're just going to simply print everything out on the page again. All right, so gallery, inline block, vertical align top, file name, embed the image. Then we're going to put the description below it. Have the gallery. And so we're going to say what the search prompt is. So the query, we're going to print out what the search prompt was, and then we're going to put the gallery there. We're going to simply print everything out, the header and the body, and that's what we got. Man. Are we done yet? This is a lot of words. So many words. Oh, Jock. What's up, Jock?
Sorry to keep asking so many questions. So I know we're probably done, and this is like how you're showing this is very simple, how we're doing this. So my question is this is how like kind of like Apple and Google is taking all our photos that we probably uploaded, doing the same type of pattern so that say for instance, we're trying to search our own photos or like all the photos with a cat in it, all the photos with a dog in it, or I took a picture of my license plate number. And so because they already broken down each photo the way we broke it down. And in the description, if it matches a request, they can just bring that image up. Kind of like, is that what we just showed us is kind of like what they're trying to do now with our photos? Like Google and Apple with this intelligence like you're talking about, in a sense?
Yeah, so basically, so this is all being processed on the servers. I mean, servers, local computer. But yeah, that's where they're talking about with the Apple AI. And so why they want you to buy the next whatever crap that they're selling is essentially they're going to have this type of system. It will actually be local on your computer or on your device. So it might be your computer, it might be your phone. And so basically when you take pictures, and again, we talk about the whole processing, right? So as you take pictures or as you import pictures, it will simply rotate through its little routine, dump that information into its database and whatever information it's looking for. And then when you do a search, that's the important thing to understand. When you're doing a search, you're not actually searching on this. You're actually searching on whatever text, indexes that they created. Yep.
Thank you.
And scene. So I hope these DIY classes make a damn bit of sense. I don't know. I always feel very hopeful going into these particular classes. And then I feel a little depressed coming out of them. As we go, they will get better. As they will go, they will get better. So that's basically the idea here. And again, like I say, the idea with this is trying to show you kind of sort of, you know, how you can start building these solutions, and also how you can start trying to present these to the decision makers at your company. You know, one of the things I used to tell my employees, it's very important to understand, it is companies and even people, they're not buying computers, right? It's gonna blow your fucking mind, right? Nobody buys a computer. Nobody buys a server, right? Nobody buys a PlayStation 5. I didn't buy a PlayStation 5. What did I buy? I bought way too many days of entertainment. I bought entertainment that supposedly never ends until you get bored with it and you turn the damn thing off, right? That's what you're buying. You're buying the solution. What is the solution worth? And again, that's where, and again, I know I sound snarky with this, especially with the employees out there. Sorry, it's true, right? But this is where you get into employees between decision maker. You get into the argument between decision makers and employees, right? Employees have this idea of, oh, you're getting ripped off. I can't believe you spent $20,000 on a Raspberry Pi. And again, here's the boss. The boss did not spend $20,000 on a Raspberry Pi. The boss spent $20,000 on a device that eliminated one full-time employee. And again, that's that. One full-time employee is $40,000 a year plus benefits. I paid $20,000. I saved $30,000 my first year. I'm a happy, happy, happy boss. I didn't buy, you know, a Raspberry Pi. I didn't buy a computer. I didn't buy a server. I bought the solutions. And so that's trying to show you this kind of thing is, again, that idea of how can you start building, you know, overall solutions for your companies. You know, that's one of the big things now, like here in the Asheville area, we have an AI meetup. And to be clear, I actually sponsor the AI meetup. As snarky as I might be about it, I do sponsor the damn thing. One of the things I find funny with it is everybody coming to the AI meetup, all they're talking about is crappy ass platforms. Like, oh my golly, everybody needs to learn ChatGPT. Like, it's so weird, right? They come, they spend their time, they spend their energy, and they're all like, oh yeah, the future is plugging a prompt into somebody else's platform. And the funny part is I keep raising my hand and I'm like, you know, it doesn't take much more work to learn how to actually build your own systems. Like we have somebody that comes that actually owns a marketing company. They own a marketing company, have 30 employees, and they love AI. But it's all through ChatGPT. And one of the things I keep trying to explain is instead of being the employee that knows how to use ChatGPT for your company, imagine if you're the employee that designs a customized AI platform for your company that every other employee in the company is using. Where do you think you're going to be on the laid off list at that point? And I think that's the important thing to start thinking about with this kind of stuff is, again, how do you start building these solutions to really add value to what you're offering to the employer, the customer. And so this is some of the stuff. Again, I know it's kind of simple, but I think it might be useful. David, what's up?
So do you have plans for future classes to show how to actually train a model or do NLP and build LLMs, or even fine-tune LLMs and stuff like that?
We might do some fine-tuning. The problem with training models is, as far as I've done the research on it, it gets bloody expensive. I was watching one, and again, to train a pretty basic model, it was like $1,500 because I'm not going to buy the GPUs, and so you basically rent essentially server infrastructure from somebody else, and to do the full training, it gets
right. But I mean, if you don't need a 70 billion parameter model, right? You can make a 1 million parameter model, and just to learn the you know what I mean? Or would that just not be useful?
It might be. I mean, again, I've got a ton of stuff to teach you folks, so it's kind of like one of those where I get to in the process. So
gotcha.
Yeah, it's one of those things. I'm not. Well, yeah, man. What?
All your classes are awesome, so I appreciate what you're doing anyway.
All right. Okay. I think that's one of that's like with a lot of this stuff. Again, it's that resource and the cost. Like this doesn't. Again, this cost me like $2 for doing it today. Some of this other stuff. Again, you kind of get into the weeds. And, yeah. What do you teach people? When do you teach people? I don't know. I'm still figuring it out. Again, as I will tell you, come back in 5 years. In 5 years, this is going to be a spit polish machine. I still got another couple of years until that happens, though. Let's see here. Any other questions? So let's see here. Sorry, this might have been covered in another. Whoops. Oh yeah. If you have an actual question, actually raise your damn hand. Raise your hand. I will go through the chat just to scan, but if you have a question, raise your hand. Makes it a lot easier. Sorry if this might have been covered in another class, but for the gallery processing project, could we ask it to find a specific thing in the images and return a certain response, create a certain action? Yeah, I mean, how well it will work, I don't know, right? So basically, I think, so you could feed it an image, and then you could ask for something very specific. The thing that you do have to remember is every image you send up, it's costing, I'm not sure how much this costs. This costs more than the other crap, right? So creating a picture costs 4 cents. I don't know, this might be like a penny or something. Anyway, so this does cost money. So one of the things that you need to do is you don't want to send 50,000 images or even 1,000 images all up without some kind of like pre-processing system going on. So like what you might do, like what you might think about is if you had all these images and you initially needed to catalog them, like what you could do is you could initially catalog all your 1,000 images. And then let's say you had a company that sold dog outfits. Hey, Roxy has some good clothes. Anyway, so let's say you sell dog outfits. So what you could do is you could process all the images and get a response like this. And then after you do that, you could fire off another script, or basically a modification of the first script, that would say, select any image that has dog in it. And then when it comes back with the images with dogs in it, then you could say, please describe the color and style of the clothes the dog is in. And then you get those results. And so instead of asking what clothes the dog is in on this, then you would only be doing it on the appropriate images. And again, that's where, again, I keep talking about the whiteboards. Again, when you go into any tech company, the reason whiteboards are everywhere is our job is much more about this than it is about that damn code. And so that's the kind of stuff that you kind of have to think about and consider. Let's see. Training models locally takes a lot of time, and there's vectorization and actual training. A small model that is useful would still take hours at the very least. Yeah, and that's where I get into the whole question of, is it worth the time to train models? Especially too, like with Ollama. I mean, Ollama already exists, and that's one of the things you have to think about. Like Ollama. If you don't know about Ollama, Ollama is amazing. We've already done a class on Ollama. We'll do more stuff on Ollama, but this is where you can run large language models, but you can also download them. So this is a framework for running large language models on your local system. It actually has its own REST API built into it, and it already has all of these models that already exist. And so again, that's one of the things you have to think about. Like as a professional, you only have so many hours in the day, right? You got 8 hours in a day. Your job should end in 8 hours. Anyways, so in 8 hours, is it more effective for you to take your time to train a new customized model, or using the kind of crap that I'm showing you with databases and all that kind of stuff? Does it make more sense to use somebody else's model and then simply tweak either the inputs or the outputs to get the response that you're looking for? And that's one of the big things to think about. Again, like that's the whole, there is no right way to do anything. There's literally how many resources do you have. Like if somebody came to hire me, you can't hire me. To be clear, I'm 1 penny more expensive than you're willing to pay. If you're like, Eli, I'm willing to pay this much money, I'll be like, oh, too bad. I need 1 penny more. 1 penny more than that. What? Anyways. But if you were going to hire me, right, again, like my biggest question to you as a decision maker is what are your resources? What are your basically when I look at it is what are your expectations? What legacy horse crap do I have to integrate with? And what resources do I have? And the resources might be developers or network admins or those types of things. Resources might be a damn server farm, right? God knows. Or resources is just pure hard cash, the best resource in the world, right? But that's going to be the thing is it's not. So many times people get caught up in the technical crap. They get so focused on on figuring out the best quote unquote best technical solution that they kind of forget the fact that if you don't have the resources, it doesn't matter, right? If you need to be if your boss says to train new LLMs or whatever, and you can't afford an H100 or whatever the hell they're called, doesn't matter. I mean, that's the thing. If you tell me to train a model and you give me a Raspberry Pi 5, I mean, sir, yes, sir, I'll do my best. Still kind of suck. So, yeah. Oh, let's see here. 410. Just a reminder, Ollama is compatible with the OpenAI API. Apparently it is. Again, so you can do an OpenAI-ish query to Ollama. Again, I don't know if your environment, it makes sense. Got it, thanks. The board is very helpful. Idea for home modifications. iPhones already have some light IA with character and object recognition. Yep. 8 bits. UTF-8 means every character is stored in a collection of one or more up to 4 8-bit numbers. ASCII means every character is a single 8-bit number. Yeah. I'm sure I learned that at some point. Again, there's so much in the technical world. There's so much. Again, what you have to understand, like, again, so I've been doing this since 96. Like, I don't, if you gave me a brown box, and you gave me some troubleshooting equipment, I wouldn't know what to do with that brown box anymore. Right, again, I had my MCSE and NT 4.0. Do not ask me how to promote a BDC. I do not remember. So yeah, that's one of the things with a lot of this stuff, and that's where like with you and your job, what you have to figure out is if your brain can only handle so much information at one time. One of the things that you do have to think about is prioritizing the information that goes into your brain. Right, and I think that's one of the things, like a lot of people get really into this whole, like, I want to be a real professional. And so they just learn so much crap that they never use, they don't use, their company doesn't, nobody cares. And so one of the things to think about, like if you want to move ahead in your career, one of the things to really be considering is filling your head with the stuff that will actually move you forward. Right? That makes sense. And yeah, the exact formatting for ASCII and UTF-8, I'm sure I knew it at one point. So anyways, there we go. That is the DIY. I've been here for over 2 hours. Are there any questions? Any questions? Any questions? No questions. Awesome class. No problem. So yeah, our next class is actually going to be a class. And this sounds weird to say, but I do think I'm going to enjoy teaching regex. I think teaching regex is going to be a hell of a lot easier than this crap. So anyways, we're going to have regex as a class on Friday. So that's regular expressions. Basically allows you to easily pull out data based off of patterns anyways, show you how to do that on Friday. I do think next Tuesday we're going to have a class on cybersecurity. And then, I don't know, we're going to have another class. So I think we're probably going to do 2 classes a week. I wanted to do 3 classes a week. But honestly, this is a bit harder than I thought it was going to be. Oh, there's expectations, and then there's reality. Anyway, so we're probably going to do about 2 classes a week. So I think we're going to do cybersecurity on Tuesday, so you guys start to understand that a little bit better. And again, start to understand the whiteboard concept of how cybersecurity actually works. And then Friday, we'll do another class. And again, like I say, we're just going to keep rolling, going to keep going. This class or this session will be up on YouTube probably tomorrow. It does take a little while to process in 4K. The nice part I will say is if you want to go back, the other camera is actually doing 4K. In 4K, you can actually see all these little tabs. So again, if you got confused with any parts during the class today, you just need to look at things a little bit better. That camera is actually better. So that'll be up tomorrow. Yeah, so if you've got no questions, I shall call it a day. Looks like there's no questions. Cool deal. See y'all next class.